In this video, we're going to be working through a couple of examples on finding the surface area and volume of a hexagonal pyramid. A hexagonal pyramid is a pyramid whose base is a hexagon. We will be concerning ourselves with hexagonal pyramids whose bases are regular hexagons. The height of the pyramid is the distance from the vertex of the pyramid to the center of the hexagonal base. And just for review purposes, reminder with any pyramids or with cones, we have the height that comes from this vertex down to the center of the base. We call that h. The apothem, which extends from the center of the base to the midpoint of one base edge, and that's referred to as our lowercase a. And then the slant height that comes from the vertex down to the midpoint of that base edge, and the slant height is referred to as L. Remember also that because these three values form the lengths of the sides of a right triangle, the Pythagorean Theorem applies. So a squared plus h squared will equal the slant height L squared. Just below that, we have the formulas for the surface area and volume of pyramids. The surface area is the area of the base, so in this case the area of a hexagon, plus 1/2 of the perimeter of the base times the slant height, and the volume is 1/3 times the area of the base times the height. So with that in mind, we begin looking at example 1. Now here in example 1, we have two values given. Remember, you want to pay close attention when looking at your diagrams to determine if you're given the height or the slant height, and you also want to pay close attention as to whether or not you are given a, the apothem, or whether you're given a radius value. And remember, the apothem extends from the center to the midpoint of a side, and the radius extends from the center of the base to a vertex, which is what we're given in this case. So we're going to start in this case by identifying first of all that 9 represents the length of the height. So that's going to be our h value. So h equals 9. That much we know already. Now let's deal with that hexagonal base. I'm going to use my little template here, draw myself a hexagon so that we can start marking it up. All right, we have a radius, as we said, that extends from the center of the base to a vertex. Go ahead and draw one of those in. As we've done with our regular hexagons in the previous exercises, we will then draw another radius into our diagram. Remember, what that's doing is forming an equilateral triangle, which means this side would also be 6, and the length of this side of the polygon is also 6. From that, we can determine the perimeter of the polygon is 6 times 6, or 36 units. 6 sides, 6 units long each. Okay, now on to finding the area of the triangle. The area of the triangle, we start by drawing in the altitude of that triangle. Since the triangle is equilateral, the altitude divides this side into two parts that are each 1/2 of 6, or 3 units long. Use our special 30, 60, 90 relationships. Take the short leg times the square root of 3 to get the length of the longer leg. So 3 times the square root of 3 becomes the length of that height, or the altitude of the triangle. All right, let's find the area of the triangle. The area of the triangle is 1/2 times the base of the equilateral triangle, the entire side there is 6, times the height of the triangle, 3 square root 3. As we've done before, we'll multiply these values that are the rational values out, and we'll keep the square root of 3 as part of our product. So 1/2 of 6 is 3, times 3 is 9, square root 3 for the area of the triangle. The area of the base, capital B, is 6 of those triangles, so 6 times 9 square root 3 gives us a value of 54 square root 3. And the last thing that we need to find, and this is so that we can use it for our surface area, is the value of L. To do that, we go back to our Pythagorean theorem. The apothem squared plus the height squared is equal to the slant height squared. In this case, the apothem, remember the apothem is the height of the equilateral triangle. The length of the apothem is 3 square root 3. And you want to keep that in parentheses so that the entire quantity gets squared. H, we know previously, is 9 units. So this becomes, plus 9 squared equals L squared. And now onto the calculator. 3 square root 3 squared plus 9 squared gives us a value of 108. So 108 equals L squared, which means L would be the square root of 108. Now we could take the time to simplify this at this point, but it's not necessary to do so because that's not our end result. Remember, we had to find L so that we can determine the surface area for this particular pyramid. So in this case, I'm just going to leave that L in that square root form. Once you have all 4 of these values, H and L, capital B and capital P, then you're ready to determine your surface area and volume. So surface area, the area of the base plus 1/2 times the perimeter of the base times the slant height. Substituting in the appropriate values gives us 54 square root 3 plus 1/2 of 36 times the square root of 108. Type that directly into the calculator. And we get a surface area of 280.59 units squared. And you may recall that throughout this chapter we've said we'll be using 2 decimal places in our solution. All right, on to the volume. Volume is equal to 1/3 times the area of the base times the height of the solid. So in this case, V equals 1/3 times 54 square root 3 times 9. Now you could simplify this by taking 1/3 of 9 and then multiplying by 54 square root 3 if you so were inclined to do so. So the volume in this case, 280.59 units cubed. And it happens to be that we have the same answer for both the surface area and the volume. Of course, that doesn't always happen, but it is a possibility. And that takes care of our first example. Okay, so on the back of your page contains the second example. If you'd like to pause the video and attempt this problem on your own, now would be a good time to do that. And then come back and visit us again once you're ready to check your solution. Okay, so in this case, we have our hexagonal base. And we're going to start by finding the 4 values as we did before, capital B, capital P, H, and L. In this case, we are given the height as 17, and from the center to the midpoint of the side, which is the apothem, is 3. All right, so we start by drawing our equilateral triangle, both those radii. And in this case, we're working toward finding the length of this short segment here so that we can determine the length of the side of the hexagon itself. To do that, we call this length x and use our 30, 60, 90 relationships. X times the square root of 3 equals the longer leg 3. Divide both sides by the square root of 3 and rationalize. You should be starting to recognize that this is a fairly repetitive process when it comes to hexagons. Now in this case, we have 2 whole number 3's. So when we take 3 divided by 3, that gives us a 1 square root 3. We don't typically write the 1. So the length of that short segment x is root 3. The length of the side is twice as long as that portion, so twice that length becomes 2 root 3. All right, now from that, determine the perimeter. We have a hexagon with 6 sides, each of which is 2 root 3 units long. So the perimeter, 12 square root 3. Okay, next thing we need to do is determine the length of, determine the area of the equilateral triangle. So we know the length of the base, we know the measurement of the height, which means we have everything we need to find the area. So the area of the equilateral triangle, 1/2 times the base of the solid, base of the triangle, 2 square root 3, times the height of the triangle, 3. Half of 2 is 1, times 3 is 3 square root 3. The base of the pyramid consists of 6 of these triangles. So capital B will be 6 times 3 square root 3, or 18 square root 3. Now for the slant height. The slant height is determined using our Pythagorean theorem. A squared plus h squared equals L squared. Our A value is 3. The h value is 17, as was given. So 3 squared plus 17 squared, 298, equals L squared. So L will be the square root of 298. And there again, it's not the final result, so it's not necessary, unless it's a whole number, to really concern yourself with simplifying that value. Okay, so now that we have all 4 values, let's determine the surface area and the volume. Surface area, the area of the base, plus 1/2 times the perimeter of the base, times the slant height. Calculator. Surface area equals 210.58 units squared. The volume, 1/3 times the area of the base times the height, 17. Gives us a volume of 176.67 units cubed. And that is how you determine the area of the surface area and volume for a hexagonal pyramid.